Hey Max. Hey Max, how are you doing?
Good, thanks. How are you?
Good. Yeah, thanks for coming to the consultation. Yeah, the second one. In the last consultation, there's only one student. So you're the first one today, and the second one totally. How's everything?
Yeah, everything's good. How have you been?
Yeah, good.
That's good.
Yeah. So any other questions that I can answer?
I've got three questions.
So your voice is a bit low. So can you please make it a bit louder? Yeah. So I've maximum my volume or the volume on the computer already. Yeah.
How's that?
Yeah, better. Yeah.
Great.
Yeah.
So I've got three questions.
Yep.
One's kind of like a topic question. The other two are just kind of about the exam. So the
Yep.
first one, it's about convolution. So in convolution, I noticed in the lecture slides,
Yep.
when we had like say like a 5x5 matrix or something and a 2x2 kernel.
Yep.
The actual convolution matrix, like their answer, isn't a 5x5 matrix. You lose like the outside row.
Yeah, lose the outside row. Yeah.
Or the outside like kind of perimeter kind
Yep.
of thing.
Yep.
But
Yep.
when I did it in MATLAB, it seemed to not get rid of the outside rim.
Yep.
So I was just wondering which is the correct way to do it.
Okay, sure. So I think those are correct. So there are some way to deal with the outside rim if you want to keep the original size of it. All right. So if it is a calculation in the final exam, then you don't need to think too much about outside rim. All right. So if it's 5x5 image on a 3x3 kernel, then you don't have to think about the outer ring. That's totally fine. So if it's in the final exam, but I mean in the real case, there are some. I mean, if you want to just do a convolution, then you don't have to think about the ring. But if you want to keep the original size of the original resolution of the image, then there are some way to deal with that. Yeah, something like that. I think MATLAB is doing that way.
Yeah, I'm seeing. So it does it as if it just has 0 on the other side. Like it kind of extends it, I guess. So it gives the original image an extra ring of zeros around it, and then it just convolutes. Anyway.
Yeah, something like that. Yeah.
So for the final exam,
in the final exam, if there is a question about that, don't worry about outer ring. Just delete the outer ring. That's totally fine.
Cool.
Yep.
So next question's about just the final exam. I was just a bit confused by this 2 hour 40 limit, 2 hour 40 minutes to do it. So I just wanted to know if I started at 12 o'clock, so when the exam starts, do I have to submit by 12:40 or can I submit it at 6 p.m.?
Okay, so if you start at 12, then you have to submit it at 2:40.
Gotcha.
Something like that. Yeah. So it's I don't want to make it that long window, but this is required from the uni that I do have to give a 6-hour window. But I really don't like that. It seems like let me tell you the whole story, the whole rule of it. So the rule is the maximum length of the exam cannot be over 2 hours and 10 minutes. Excluding reading and the submission, something like that, right? But we have to create a 6-hour window that the students can start with a flexible time, especially for someone who are not in Australia, for example, in Europe or the US, something like that. Yeah, but the thing is, the longer the time, then there will be some cheating after that. Right? Yeah. If you take like 6 hours to do that, there's a lot of things students can do. So I really do want to do that. But so what I'm doing now is, I think I mentioned a little bit before. So what I'm doing now is I'm asking students if they can't start at 12. If they can't start at 12, then the students will let me know. That's the first thing. And the second thing is, so I suppose most of students, they are able to start at 12. And then there will be 10 minutes reading and 2 hours like answering the questions and 30 minutes to submit the question to the test online, something like that. So totally 2 hours, 40 minutes.
Yeah.
All right. So if someone is later than that, and without asking me, well, sorry, without telling me that he's doing that later than 12, then I will give the students an interview.
Gotcha.
Something like that. I think this is protecting students, someone like you, right? Yeah. I know you're good. So yeah, something like that. I think it's a way that to make the make the final exam a bit fair to all the students.
Yeah, that sounds. I was just wondering if I had 6 hours, I probably would have done a bit less studies because I would have had time to kind of look up the answers a bit more. But,
yeah. Okay. So please start at 12 and finish at 2:40, something like that.
No worries. Thank you.
No worries. Yeah.
And the last question, I noticed you said we'll have matrices more than 2 by 2 that we'll be dealing with.
Yeah.
And so I imagine you don't. So like when I'm calculating eigenvalues, so there's a couple of steps there for a 2 by 2 matrix.
Yeah.
But for a 3 by 3 or whatever, I don't really know what to do. So I can just say like handwrite using MATLAB, the eigenvalues are, and whatever they are. Is that? That's totally fine.
That's totally fine. That's totally
gotcha.
Fine.
Cool.
Yeah. So I'm explaining a little bit to you about the eigenvalues like more than 2 by 2. The calculation, I mean, this is nothing related to the final exam, but I'm letting you know about how to calculate it by hand. So the progress is similar. So do you remember the AE matrix minus lambda times identity matrix?
Yeah.
Right, and then you make the determinant equal to 0, and then you calculate the lambda, right? And then if A is 3 by 3, then your identity matrix is 3 by 3 as well.
Yeah.
And then there will be a like third order like equations that you want to solve. And then there will be, I mean, the answer will be the lambda as well. The only thing is the third order equations, they are quite hard to solve.
Yeah.
Yeah. So
gotcha.
Yeah, feel free to use MATLAB to calculate it if it is more than 3. But I mean, what I mean is because you have the ability to use MATLAB or like C or something, and then it is not limited. So the dimensions of matrices and the calculations are not limited.
Okay.
Yeah. So do make sure your MATLAB can work during the exam, and then do use MATLAB to check your to double check your answer and do some calculations.
Right. So
and also, yeah. Sorry. Yeah. Keep going.
Are you saying try and write it out as much as possible? So like all the steps for calculating the eigenvalues or whatever, but just double check. Like, so I don't have to worry about solving the 3rd order or 4th order or 5th order or whatever it ends up being.
Yeah. You don't have to worry about solving the hard questions, but just write as many as you can, and then do the calculation on MATLAB. That's totally fine.
Cool.
That's totally fine. Yeah. So the calculation. So supposing if you have question with 3 by 3 AE matrix, then you can do you can calculate eigenvalues by using MATLAB, and also do remember if A is 3 by 3, then if you check the controllability, then the controllability will be like 3 by n dimensions, right?
Is it 1 by 3?
It's not 1 by
4.
It's not 1 by 3. It's 3 by n, I think. It's 3 by n. N can be anything, but I mean you can choose a set of 3 by 3, 3 by 4, 3 by 5. That's fine. And then you can check the rank. You can check the rank.
Yeah.
By just using a function.
Yeah.
And then the only thing is if you have a matrix which is for example, which is 4 by 6, it's not a square matrix. Right? And then if you use the rank function, it returns you the rank is 4. Is that 4-row rank or not?
I'm not sure.
It is, yes, right? So 4-row rank means if you have 4 rows and then your rank is 4, that is 4-row rank.
Gotcha.
Yeah, so if it's a square matrix, then the row rank will be equal to the column rank. But if it's not a square matrix, the 4-row rank means the rank is equal to the number of the rows, something like that. But I mean,
Gotcha.
just use the rank function. You can get the rank of the matrix, something like that.
Gotcha.
Yep.
Okay. That's helpful.
All good?
Yeah, that's all good.
Okay, cool. So thanks for coming. So
I'll just stick around and see if anyone else has any questions.
Yeah, sure. And I will be in the Zoom meeting from now to 12. So feel free if you have any other questions to ask me. And also the same time tomorrow, I'll be there as well.
Cool. Awesome. Thank you.
All right. Thanks, Max. Hey, Johnson. Yep. How's things?
Yeah, it's good. I just had a question about the optimal control.
Yep.
I was just going through the lectures and there weren't any examples done by hand or usually done through the MATLAB. Would we be expected in the exam to do them by hand or?
No. I think I've answered the questions from Max. So the thing is, you. I mean, it is online take-home exam. Then you can use MATLAB.
Okay.
You can definitely use MATLAB. So what I suggest is, if there's a question, and the question requires some calculations, right?
Yep.
So you can write as many or as much as you can, and then do the calculations from MATLAB.
Okay.
This is something you can do. All right. So let's come back to the optimal control.
Yep.
Let's come back to the optimal control. So if there is a question about that, so think about what kind of question I can ask. Based on the resources that you have, then you can answer the question.
Right.
Think about it. So if there is something about the optimal control, if I'm not saying that it definitely is, but I'm saying if. So you can. So the question can either be a short answer questions, which means you don't have to do any calculation, but only explaining about how to do the optimal control.
Okay.
Right? Or I'm asking you to do this kind of like calculation about doing this optimal control to getting a K, optimal K. Then you can write the steps. You can write the equation, necessary equation, write the steps as many as you can. Then you can come back to MATLAB to do this calculation.
Right. Yeah.
So it can be either the calculation or the short answer question. So if there's calculation, you can use MATLAB, definitely.
Yeah, okay, that makes sense.
Yeah. Yep, cool. So other questions?
That's all I had.
Okay, cool. So yeah, I'll be here today and this morning and tomorrow morning. So feel free to come back and ask. Yeah, thanks, Johnson. And Sabrina?
I'm just kind of here listening to other people's questions.
Yeah. Okay, yeah, sure. Yeah, so if you have questions, just let me know. Yeah.
Yeah, easy, will do.
Yeah, sure, cool. Thanks. Yeah, I'll be here waiting for others. Yeah. Yeah, and one quick thing to mention to all of you. So if there is a question with few sub questions, and like similar to what you have in quiz 2, then if some sub-questions are based on the previous sub-question, and if you do not know the answer of the of the previous sub-question, then you can assume something and still answering the following ones. If you leave it blank, then that'll be horrible, right? You can't get marks. But if you can still like assume something and then answer the following questions, then you will get marks. At least you will get some marks at each of the questions. So this is what I mean. So never leave things blank. If some of the sub questions are rely on the previous one, and you don't have the answer for the previous one, then you can assume you have an answer, and then based on that kind of answer the following questions. Then you can get marks, something like that. Yeah. So again, let me wait for the others. Yep. How are you doing?
Yep. Just on the exam.
Yeah.
It'll be uploaded to UTS Online.
UTS Online. Yeah.
And are we expected to be in a Zoom room, or can we just do it straight away?
Yeah, that's a good question. So I think a lot of people are confusing about this kind of like online take-home exam. Yeah. So the exam is like you don't have to be in a Zoom room.
Okay.
Just download it and do it yourself. But I will be in this room in the same like Zoom ID for the first hour. If you have some questions, I'll be there and to answer your questions. All right. So just download it and answer the question and submit it via the UTS Online as well.
All right. Okay.
Something like that. Yeah.
Cool.
Pascal, do you have any questions to ask?
Yes.
Yeah.
For the lecture about nonlinear discrete system.
Yeah, the nonlinear discrete system, right? Yep.
Yeah. For the state feedback control question on the last slide of the presentation.
Sorry. Wait a minute.
You want me to share my screen?
Yeah. So I will allow you to share the screen. Yeah. Please share the screen.
Can you see the question?
Yeah.
Yeah, so for this question, where it says here let a minus kb equals 1 minus root 2.
Mm-hmm.
Where do we find this value to make it equal to a minus kb?
Let me have a look. What's the question? All right, so that is not stable. If x is equal to that is not stable. Okay, so it's applying state feedback control. So it's some kind of like probe placement. You remember that? Hello?
Yes.
Okay, so that is probe placement. So if the equivalent point is equal to square root of 2, then it is not stable, right? It is not stable because your a is 1 plus square root of 2, right? Then if we apply the state feedback control and probe placement, then the state feedback control is you replace the delta u, which is the control, the linearized control, is equal to minus k delta x, right? Then your new A matrix, which is A minus bk or kb, which is 1 plus square root of 2 and plus 2k. right? If you look at the 1, 2, 3, the fourth equation.
Yeah, this one.
That's a state feedback control. So you replace the delta U by K delta X, something like that, right? So then you have your new A matrix, which is A minus BK, then that is 1 plus square root of 2 and plus 2K, right? Then when you do the pole placement, it means you want to make your new K, which is A minus BK. So you want to make your new K. So you want to make your new A, which is A minus BK. That is under the criteria about stability. So which means you want this new A minus BK between -1 and 1, right? And then you can choose any of the values as your pole. That's the pole placement, right? Then if we choose A minus BK is equal to 1 minus square root of 2, then it is stable, right? Then you can find your K is minus square root of 2, something like this. Yeah, so that is why we make A minus BK is equal to 1 minus square root of 2. So you can choose any of the poles you want, but make it stable, something like that.
Okay, is it because like we choose this value because in the above example it's stable at 1 minus, where is it?
Yeah, so in this question, the first is about the linearization, right? Sorry, the first is about the calculating the equilibrium, right? And then the linearization. Then because the equilibrium you have two equilibrium points. Then you can linearize it at 2 points, the two equilibrium points. Then if the equilibrium point is minus square root of 2, then that is stable, right? Because your A matrix is 1, if I remember correctly, 1 minus square root of 2. That is between -1 and 1, right? And then if you choose the equilibrium point as the positive square root of 2, then your A matrix, a linearized A matrix, which is the second equation, which in the second equation in this page, the second one, yeah, says 1 plus square root 2, right? So the eigenvalue of that, so it is it's a scalar, so the eigenvalue is the value itself. So the eigenvalue is more than 1, then which means it is not stable. Then we want to do the pole placement. So the pole placement, it applied the state feedback control. So which means it used the minus kx, minus k, in this case, minus k delta x is equal to the delta u, which is the third equation, right? And you put it back into the original, which is the second equation. Then you get your fourth equation, right? You get your fourth equation. And in this case, the new A matrix, or no, here is the new A value is 1 plus square root of 2 plus 2k, right? Plus 2k. And you want to make this value between -1 and 1. And I think you are asking why I'm choosing 1 minus square root 2, is that right?
Yeah.
Okay, so for the pole placement, you can choose any of the pole, but you want to make it stable. All right, so this is what I choose. So it's flexible for you to choose any of the pole, but make it between -1 and 1. Is that right? So I choose the pole as 1 minus square root of 2. So which means your A minus BK, which is 1 plus square root of 2 plus 2k is equal to 1 minus square root of 2. Then which means k is equal to minus square root of 2.
Okay, so it can be any value that makes A stable.
A minus bk. A minus bk has the eigenvalue between -1 and 1.
Okay, yeah.
Yeah, so you can, so for pole placement, you can choose any of the poles, which means you can choose any of the eigenvalues which make the new A matrix stable. Which means you have the new, you can make your new A matrix, A minus bk, has the eigenvalues between -1 and 1. You can choose any. But why we are introducing the optimal control is because for pole placement, you can choose as many poles as you can, right? So you have multiple options about the poles, but which one is the best? That's the optimal control. The optimal control tells you which one is the best.
Yeah.
Yep. Yeah.
Okay. Thank you.
No worries. I think yesterday you sent me an email, right? So on Friday you sent me an email.
Yes.
About the projections. Oh, sorry, about recover the 3D position of the point from the 2D UV. So you said that, right? Yeah. So the question is that you can't recover the 3D location of the feature or of a point from one single 2D projection. You can do the projection, but you can't do it the other way around. All right, so if you have a 3D point, you can project it onto 2D, then you can calculate the position of that point projected on the 2D image. But the other way around, you can't do that from a single view. So that's why we introduced the triangulation. All right, so for the triangulation, for the triangulation for stereo camera, then you have 2 UVs, which means 2 projections on the left and right image from the same 3D point. Then you can calculate XYZ position. All right. So if you only have 1 UV, then you can only do the projection from 3D to 2D. But if it is in a stereo case, you have a pair of UV, then you can calculate the 3D point from the 2D UVs. Something like this. Yeah. All good?
Yes. Thank you.
Okay. No worries. Thank you. See you. Hamish. Hamish.
Hello. Yes.
Hi. How are you doing?
I'm not bad. Yourself?
Good. So, any questions?
I going through at the moment. I had some, but I was just getting them ready. So not just yet.
Yeah.
Thank you.
Okay. Cool. Yeah, sure. Yeah, Teresa. Hi, Teresa.
Hi, sorry.
Hi. How are you doing?
Yeah, not bad. How are you?
Good. So any questions?
In regards to the exam, do you think it'll be an even split between the whole semester?
Sorry?
Is it even use of all the subjects from the semester, or more focus on the last couple of weeks?
Sorry, I can't say too much on that. Suppose you need to prepare the final exam from the beginning to the end. Yeah.
Okay.
But the thing is, think about the final exam. It's a final exam. It's a taking home final exam, and there's no experiments on that.
Okay.
So so if you go through all the lecture notes, if something is about the experiments, then they will not be included in the final exam, right? There will be answers, short answers, long answers, including calculations, something like that.
Because I know, like the other projects, they did gazebo and a lot of ROS, and I didn't do so much for my project, so I won't have to go through the other projects.
I don't think you have to. So they will be not really related to the experiments or something about implementations.
Okay.
Yeah, but they will definitely include some algorithms we introduced in the lectures. So
okay.
yeah, go through the lectures, and I think most of the things are related to the lecture notes, something like that.
Okay.
Yeah.
So it would be nothing new, right? Just everything from the lectures, because it's an open book. So I was worried that.
I should say the knowledge from behind is nothing new, but
Okay.
but this year, because it's open book exam,
And
I make it a little bit complicated for all the students. Yeah, but the thing is you have the help from the MATLAB.
Yeah.
Yeah, and some of the questions I try to make every single student have every single answers on that.
Okay.
I try to make that, and when you find the questions, you will find it. You find how I did it. It's quite stupid, but I'm trying to make the answers from each of the students different.
Okay. All right.
but the question, I mean, the knowledge from behind is like it's nothing new. It's all in the lecture notes.
Mm-hmm.
Yeah, there will be some difficulties because you can use MATLAB or other like coding coding softwares. Then I may ask you to do some calculations which are much more complicated than before, as I mentioned in the last email.
Yeah.
Yeah. For example, in quiz 2, you only have calculations with 2x2 matrix. That's the maximum, right? But in the final exam, you may have larger. Let's say 4x4. So which means if you want to calculate the eigenvalues of of a 4x4 matrix, then you can use MATLAB. You can use MATLAB. That's quite simple, right? So with just one function. Or if you can, so if you want to check the rank of 4x6 matrix, for example, you want to check the rank of the 4x6 matrix. You can just use the rank function in MATLAB, and you get it. The only thing is before what I introduced is the matrix you want to check the rank has is square. But if it's not square, for example, it's 4x6, then it's checking if it's 4-row rank. For example, if you have a 4x6 matrix and you check the rank which is 4, then it is the rank is equal to the number of the rows, which means it is 4-row rank. That is controllable, something like that. So some calculations, they will be like much more complicated. But the good thing is you can use MATLAB to help. Okay. All right, so that is one thing, and some other things like similar. So if previously they can't be calculated by hand, for example, the pseudo inverse of the visual serving. So if it's before it is restrict open book, then you can't calculate it. But now it can be calculated. So which means this kind of questions, they can be calculations as well. Yeah, it looks like a bit complicated than before, but because you can use MATLAB, then something are solvable, right? Yeah.
So you're saying like the maths will be more complicated, but the concepts are not going to be, there won't be like extra steps or something?
Yeah, the concept will be similar. So the concept will be like everything from lectures. Yeah.
Okay, good. All right. I was a little bit worried. Yeah.
Okay, cool, thanks. And yeah, so yeah, another thing I want to mention is what is that? Just through my mind. All right, let me think about it. I'll talk a little bit later. Sorry, I suddenly forgot it.
All right, thanks for that.
All right, yeah, sure. Yeah. So one thing I just mentioned is there may be some questions with sub-questions, and some of the sub-questions are rely on the previous question. So which means if you can't answer the previous question, you may not be able to answer the following ones. But what I mean is, don't leave any of the questions blank. If you find you can't solve the previous question, and suppose you solve it, you have an answer, and based on that answer the following questions, then you will get marks. Yeah, this is what I remember. Thanks, Tracy.
Sorry, one more thing, Liang.
Yep.
Will you upload these later to see somewhere?
Sorry?
Will you upload these help sessions to
the video? You mean the video, right?
Yeah.
Okay, yeah. So can I ask all of you in this room, so do you mind if I'm submitting this video to the UTS Online?
I don't mind. It's because yeah.
Yeah. So Max, do you mind if I upload this to the UTS Online?
That's fine.
Okay, cool. So Hamish?
Yeah, no, not at all. That's fine. Okay,
that's great. Yeah, I'm recording. So I'll upload it online. So you don't have to wait in this room, right?
Yeah.
Yeah. Cool. So Max and Hamish, you don't have to wait in this room. Yeah, I'm going to upload it. Yeah. Yeah.
Alrighty. Thanks.
No worries.
Thanks for being available.
Yeah, no worries.
All right. Bye-bye.
See you.
Thanks, Liang. I'll see you later.
No worries. See you. Bye.
Yeah, thank you. I'm gonna prepare my questions a bit more.
Yeah.
I'll be back. Thank you.
Yeah, sure.
Hey, Liang.
I said, hey, how are you doing?
Pretty good. How are you?
Good.
I just wanted to ask you about the final exam. Like, what should I be looking into? Like, how should I be making the scripts, stuff like that? Like, any advice that you might have for me?
Okay, so how should you prepare? It's a good question. So I can't answer too details about that.
Oh,
so my suggestion is go through every single videos and lecture notes that you have.
Okay.
And think about it as a final exam, then which means there is no experiment.
Okay,
all right. So think about some questions that you can answer in the final exam, but they are not the experiments. So which means I can't ask you to log some data from RGBD sensor or laser. So that's not the case. Yeah. All right. So there must be short answer questions or long answer questions, including calculations.
Okay. Are there going to be any flow charts or pseudocode stuff like that?
I don't expect you to write some flow chart and pseudo codes, but for some of the calculations, you need to write the necessary equations. And when you do the calculation, you can get help from MATLAB. It is open book, so you can use MATLAB. So
like
make the MATLAB ready. It really help in the final exam.
Oh, okay.
Yeah.
So if I use something from MATLAB, do I have to like put it in the final exam script that, oh, I use MATLAB for this, or this is the equation that I use from MATLAB? Do I need to put anything like that, or?
Okay, so never copy the MATLAB code to the answering paper.
Okay.
Never do that. So you can write all the necessary equations, but when doing the calculations, then you can get help from MATLAB.
Oh, okay, I get it.
For example,
yes.
If let's give the example on the quiz 2, the second question on quiz 2. So you want to check the stability of that system, right?
Yes.
Then you need to calculate the eigenvalue.
Okay. Yep.
Right. So you write everything you answer to that question, but when you do the calculation of the eigenvalue, you can get help from MATLAB. In MATLAB, it's just a function, right?
Yep.
EIG is just a function. Then you can get the eigenvalues, and then put the number of eigenvalues back. Then write your conclusion if it's stable or not, and what's the criteria.
Okay.
All right, something like that. This is just example. And for example, if you want to calculate, if you want to check the controllability, which is the last sub question in your quiz 2, then when you do the calculation, it's just b and a times b, a squared times b, something like that. You can write the necessary equation there, and then do the calculation from MATLAB. Then you can get the controllability matrix C, right? It's a matrix, and then you can check the rank of that by using MATLAB as well.
Oh, okay.
So what I mean is, you write everything you can to make it as a closed book, but do not closed book. Write everything you can from handwriting, but do the calculation from MATLAB. Something like this.
Okay. I think I understand.
Yeah, and because we can use MATLAB, it's open book, we can use MATLAB now. So the calculations will be a little bit complicated than before.
Okay, like when you say complicated, do you mean like uneven matrices, or like 3 into 3s, 4 into 4s, like?
Yeah, for example,
yeah.
If in before you only have 2 by 2 matrix to calculate eigenvalue, right?
Yep.
But because you can use MATLAB, I can give you a 4 by 4, 6 by 6, or 10 by 10. You can directly get the eigenvalues. It's quite easy for you, right?
Yep.
Yeah. So that's one of the example. Yeah. And another thing, another example can be that, for example, if you're doing video serving and you are calculating the pseudo inverse.
Sorry.
If you're doing video serving,
yes,
and you are calculating the pseudo inverse of the Fisher Jacobian.
Okay.
And before you can't do that by hand, right?
Of course not. Yeah.
Yeah, but now you can use MATLAB. Something like this. Those are 2 examples. I didn't mean it will be in the final exam, but those are 2 examples.
Okay.
Yeah, so for some calculations, previously you can't calculate, or it's too complicated to calculate, but you can use MATLAB to calculate it.
Oh, okay.
Yeah.
I think I understand. Okay. Because like I haven't because I just finished one of my assignments right now, so I was thinking of like starting to study like from today.
Yeah.
So I just want to go over with you what can I what should I study, how should I study for it, and how can I just get everything done.
Okay, so I can't tell you which section or which lecture you're going to review.
Okay.
Yeah, I can't do that. Sorry, but the thing is, I do suggest you go through
which lecture, which topics are more important.
No, I can't say that. I can't say that.
Okay.
It's just 30%.
Oh yeah.
It's just 30%. There will be like 2 or 3 questions with sub questions. So it is only like 2 or 3 topics. I can't say that. I'm sorry. I can't say that.
No, that's fair. That's fair.
Yeah, but the thing is, go through every single lecture notes and also the videos.
Okay.
Then think about have something in mind that I can't include some experiments.
Okay.
Then what are they? Right? So you go through every single lecture notes, then you will find so which one can be included in the final exam and which one can't. And also the good thing is it's open book.
Yeah, true.
You can use lecture notes at any time you want during the final exam. But the thing is, there's a limited time, so don't spend too much time on finding the materials. So my suggestion is go through it before the final exam.
Okay, fair.
Yeah.
Yeah. Also, so you're gonna upload the paper at 12 p.m. I believe on the 24th.
Yes. So so there's a quite complicated. I'm answering again about that. So it is. So the paper is available from 12.
Yes.
And I'm asking I'm asking all the students, they're starting from 12, if they can.
Okay.
And if they can't, please send me email.
Okay. Yep.
All right. And then it will be 10 minutes reading, 2 hours answering, and 30 minutes uploading. So totally 2 hours, 40 minutes.
Okay, so from the time I download it, I would have to finish it within the 2 hours and 40 minutes.
Yeah, something like that. Yes.
Okay. So should I time myself, or is there an internal timer that's gonna run?
Time yourself. That, I mean, I'm setting up the timers on the UTS Online.
Oh, okay. So there's gonna be a timer that's gonna run on UTS Online then.
I'm not 100% sure, but I mean, do the timer yourself. So 2 hours, 40 minutes is more than enough for you, I think.
Yeah, of course.
It's just 30%, so there are not too many questions.
Okay, fair.
I think it should be enough. Yeah.
Okay. Also, I